Welcome to our discussion of naming ionic compounds. In this lesson, we'll define and identify ionic compounds, predict the charge of cations and anions, and go from name to symbol and symbol to name when identifying ionic compounds. So before we can name an ionic compound, we have to be able to identify a substance as an ionic compound. So when we have an ionic compound, we're going to have a metal bonded to a nonmetal. And when we have this type of bonding occurring, we're going to have something called an ionic bond. In an ionic bond, we have a transfer of electrons, meaning one atom is going to give its electrons to the other atom within that compound, creating ions, or atoms that have a positive or negative charge. And as you recall from our part 1 naming video, our cations are going to have a slightly positive charge, and meaning they're the ones that have given up an electron, while our anions have a slightly negative charge because they're the ones that have accepted that electron. So if we take a look at sodium chloride as an example, our sodium is a metal and our chlorine is a nonmetal. Our sodium is going to be our cation. It's going to have a slightly positive charge because it's going to give up or donate one electron to chlorine. And chlorine is going to have a slightly negative charge and be our anion. It's usually going to be pretty easy to identify which is the cation and which is the anion in an ionic compound because our cations, our positive ions, are typically going to come first. We can also use our periodic table to predict whether an element is going to act as a cation or an anion in an ionic compound. So if you look at the top of your groups or your columns on your periodic table, you'll notice that many of them have positive or negative numbers at the top. So things like +1, +2, -3, -1. And those numbers are indicative of the types of charges that every element in that group or in that column is going to take on. So for example, every element in the very first group under hydrogen, when it becomes part of an ionic compound, it's going to take on a +1 charge, or it's going to give up an electron. Conversely, if you look at our group with nitrogen on the top, you'll notice that it has a -3. That means every element in that group or that column is going to actually accept 3 electrons in an ionic bond and have a -3 charge. Now that we have a basic understanding of what ionic compounds are and how ionic bonds are formed and how to predict charges on different elements within an ionic compound, we can start to dig in on how to name these ionic compounds. And just like with our binary molecular compounds, there are some basic rules that we can follow when naming these ionic compounds. The first of these rules is that ionic compounds are always composed of a metal and a nonmetal. And as we've already talked about, the metal is going to be our cation and it's going to come first, and our nonmetal is going to be our anion and it's going to come second in the formula for an ionic compound. And the second rule for naming ionic compounds when going from formula to name is that the compound, like our binary molecular compounds, is going to end in "ide." Do note that for ionic compounds, we are not going to use prefixes. Prefixes are only used when naming binary molecular compounds. Now let's take a look at some examples and practice going from formula to name or symbol to name for our ionic compounds. So the first thing we need to do is determine what kind of compound we have when naming. So for MgO, our first element is Mg, or magnesium, which is on the left-hand side of the periodic table, so it's a metal. Oxygen is to the right of the ladder on the periodic table, so it's a nonmetal. So we have a metal and a nonmetal, meaning that we do indeed have an ionic compound. And so that's the first of our rules. And our second of our rules just says that the name ends in "ide." So for ionic compounds, going from formula to name, it's really simple. MgO is just going to be magnesium oxide. So we just name each of the elements and stick "ide" at the end. So for our second example, we have sodium, which is a metal, and sulfur, which is a nonmetal. So once again, we do have an ionic compound. And here we have two sodiums, but remember, since this is an ionic compound, we're not going to use prefixes. So we can actually ignore, for now, that 2 and just name this like we did our first compound. So this is just going to be sodium sulfide. Remember to have that "ide" at the end, but no prefixes since we're not naming binary molecular compounds. Pause the video, try the last two examples on your own, and then hit play when you're ready to check your work. So take a look for the last two examples. You should have gotten magnesium fluoride and strontium phosphide. And once again, remember, even though there are the subscripts on each of these compounds, we're going to ignore them because we're working with ionic compounds, so no prefixes. Now let's take a look at going from name to formula for our ionic compounds. This is a little bit trickier and requires one more step or one more rule. So when going from name to formula for ionic compounds, we need to make sure we balance the charges of the ions within that compound so that the overall charge of our compound is always 0. So remember, ionic compounds, even though they have ionic bonds that are formed through a transfer of electrons, the overall charge of that ionic compound is going to be 0, or it's going to be neutral, because the positive and negative charges of our cations and anions are going to balance each other out. So let's take a look at an example to clarify what I mean. So let's take a look at sodium fluoride. So first we're just going to start by writing our formulas for sodium and fluoride, so Na and F. Next, we need to look at the periodic table and look at the charges that each of those elements are going to take on when in an ionic compound. Remember, we're going to find these charges above the groups or the columns of each of these elements on the periodic table. So for sodium, it's going to take on a +1 charge, which makes sense because it's first and it's a metal, so it makes sense that it is a positively charged cation. And fluorine is going to take on a -1 charge. Also makes sense. It's second, so it is the nonmetal and the anion. So since we have one sodium and one fluorine, and sodium has a +1 and fluorine has a -1, our ionic compound is already balanced. The positive charge of the one sodium balances out the negative charge of the one fluorine. So our formula for sodium fluoride is just NaF. Okay, let's take a look at another example, calcium nitride. So we've confirmed that calcium nitride is an ionic compound because it's made of a metal and a nonmetal, calcium our metal, and nitrogen our nonmetal, because remember our formula ends in "ide", so if we drop that "ide", we know that that's nitrogen. So the first thing we're going to do is write out our formula. So calcium is Ca and nitrogen is N. And then the next thing we do, since we're going from name to formula, is we have to look up on the periodic table the charges that each of these elements are going to take on when they're part of an ionic bond. And calcium is going to take on a +2, and nitrogen is going to take on a -3 charge. Well, as we can see, unlike our sodium fluoride, our charges aren't balanced. I have a +2 and a -3. So right now I have an overall charge of -1, and I can't have that. Remember, our ionic compounds have to be neutrally charged. So I have to somehow balance those positive and negative charges, and I cannot change the charge. However, I can change the quantity of calcium atoms and nitrogen atoms that I have within this compound. The easiest way to do this and to be able to balance our charges, and by balancing our quantities of atoms, is to use something called the swap and drop method. So what we're going to do is we're going to take the +2 charge off of calcium, and we're going to bring that down and put it as a subscript on nitrogen so that we have 2 nitrogen atoms within this compound. And then we're going to take our -3, really just a 3 from above our nitrogen, and we're going to swap and drop and bring that down to become the subscript on calcium, so that we have 3 calcium atoms within this compound. So I'm just going to replace our charges because our calcium still has a +2 charge and our nitrogen still has a -3 charge. But now I've changed my quantity, so I have 3 calciums, each with a +2 charge, and 2 nitrogens, each with a -3 charge. So to double check to make sure that our swap and drop method worked, we're going to do a little quick multiplication. So my calciums each have a +2 charge, so +2 times 3 gives me a +6. So within this compound, I have an overall positive charge of +6. For my nitrogens, I have 2 nitrogens, each with a -3 charge, so -3 times 2 is -6 or -6. So I have an overall negative charge of -6. And as we wanted, our positive charge and our negative charge, our overall positive charge and our overall negative charge balance each other out. I have a total +6, which is balanced out with my total -6. So overall, this ionic compound has a charge of 0, which is what we need to accomplish in all of our ionic compounds when going from name to formula. And that's what we mean when we say balance the charges. We need to balance the overall charges of our positive and negative ions so that our compound itself is neutrally charged. The swap and drop method will work every time and is just a little bit easier and more straightforward of an approach than thinking in terms of common denominators. But you don't have to take my word for it. Let's take a look at a couple more examples to test the hypothesis that our swap and drop method will always work. So let's take a look at lithium sulfide. Lithium is going to be our metal. Sulfur is going to be our nonmetal. Lithium is Li, sulfur is S, and lithium is going to take on a +1 charge when in an ionic bond, and sulfur is going to take on a -2 charge when in an ionic bond. So now I can take those charges and swap and drop. So I'm going to take my 1 and swap it down to sulfur and turn it into a subscript. And I'm going to take my 2 and swap that over to lithium and drop it down as a subscript. So I'm going to have Li2S. And to double check my lithium, I have 2 lithiums, each with a +1 charge. So I have an overall positive charge of +2. And I have 1 sulfur, each with a -2 charge. So I have an overall negative charge of -2. So my +2 and -2 balance out. So this compound, this molecule, is neutrally charged overall. So now pause the video, try these 2 examples on your own, and when you're ready, hit play to check your work. And there you go. For aluminum sulfide, you should have had Al2S3. And for calcium phosphide, you should have had Ca3P2. And that concludes our discussion of naming ionic compounds. Bring any questions you have with you to class.